It's the end of November, and we've gotten a lot done since the last time we talked. We have a great opportunity with the amount of framing that we have done to talk about a lot of the different technologies that we've integrated into the design to make this an energy efficient home. So I'm going to walk through the different aspects that we've implemented to help seal this house up against the weather. The first thing I'm going to show you is this sill seal. This is a rubber gasket that goes around the perimeter of the foundation between the bottom of the wall and the foundation wall. It's about 3 inches wide, and it's got kind of 2 rubber bulbs that stick out, and this is compressed by the wall as it sits on top of it. You can see that we've got 2 walls that are about 10 inches apart. We narrowed this feature from about a 13-inch wall to a 10-inch wall as we talked through the implications of moisture migrating through the wall. That's something that is a technical problem that's a feature of all of these highly energy efficient homes, and it's something that we have to manage very carefully. And the solution to this particular problem was to actually put in less insulation. So we narrowed up the walls to help us resolve what happens with moisture in the wall. It has to do with condensation of moisture and where it condenses, if it's going to condense. And hopefully we've eliminated that possibility, but if it's going to happen, we need to control where that's going to happen. We've installed plywood sheathing on the outside. You can see a little bit of it on the outside right now. And we're going to be taping all the joints, and you can see a little bit right here above the windows. And what we're trying to do is to prevent any opportunity for air to go through the frame in any way, so that you can get like a tunnel effect where wind can kind of whistle through any opening. It's okay for moisture or to move through a frame as long as it's diffused, and we get that diffusion by creating as much of an impermeable or impervious layer as possible, so that it's diffused. And plywood is a good diffuser, drywall is a good diffuser, but if there's any hole anywhere in it, then air with moisture in it will go through that quickly, and it will condense inside the wall, and we don't want that. So the objective is to seal it as well as we can. The next thing I'm going to show you is the header that we've selected here. This is called an LVL header, and LVL is really a plywood header. This is engineered for this particular building, and the advantage of using this particular header is that we only need 1 header. A typical frame construction, they use 2 2x12s with a layer of plywood between them to make it the same width as a wall, and it's much less energy efficient. By using this engineered header, I can get more insulation in the wall and gain more energy efficiency that way. A third feature, which we haven't actually framed up yet, is whenever we have a partition, one of the walls for the bedroom or one of the other walls that butts into the perimeter wall, we have to have some means of fastening the drywall to it. What we've elected to do in discussions with the drywaller is to make sure that the drywall around the perimeter of the building is continuous all the way around the building. So we're going to actually hold our partition walls back slightly and drywall all the way through around the entire perimeter of the building continuously, and then we'll have some backer material in that wall so that we can fasten to through the drywall. So we'll have that continuous barrier all the way around. Next time I hope to be able to show you we've minimized the number of penetrations that we have in the perimeter wall. Outlets. We have to have outlets. Code mandates the number of outlets that we have. We have to have them every 12 feet. And so to minimize the impact of an outlet, we've got a special outlet that has a gasketed seal, a neoprene gasket, and even where the wires go into the box, there's a neoprene seal, a double neoprene seal. So we're well sealed against the potential for air leakage through that. And the drywall butts up against that neoprene gasket. And otherwise, I've limited the number of potential openings. I've eliminated all but one ceiling outlet, and we have one chandelier that we're going to have in the building. All the rest of them have been changed to wall sconces, so and they're all on interior partitions, so that we don't have any. Excuse me, so that we don't have any, we've minimized the number of ceiling partitions. Another feature in the building here is what we call a raised heel truss. Because we're going to have between 24 and 30 inches of insulation in the attic, we're trying to achieve an R value, which stands for the thermal resistance value of 90 in the attic. We need to be able to accommodate that depth of insulation and still maintain ventilation in the attic. So this attic truss is designed to accommodate that depth of insulation. We have also designed an attic, what's called an attic truss. It's designed so that if some future owner wants to ever build this space out, that they can put bedrooms and bathrooms or whatever they want up here. The other feature that I wanted to point out here is that we're going to be putting a plywood ceiling in here, and then we'll be drywalling over that. The plywood ceiling is part of that air seal that we're going to be putting around the perimeter of the building to prevent air infiltration. And again, once that plywood is in there, we're going to be taping all of those joints. So. And part of that design required that we cover the top plates of the double wall, and you can see that right here at this point. One of the things that we were especially interested in doing in a passive design was making sure that in the wintertime that we were able to attain a solar gain through the windows. And you can see in the background here a lot of glass from the open windows on the south side. As we go through the living room here, what's particularly relevant is the amount of sunlight that you can see on the floor here. We have cast concrete, poured in place concrete that we've tinted a dark color so that it absorbs the sun's rays. And we've used very low tinting on the windows so that it will absorb the sun's rays during the wintertime and will retain that heat. If you also look at the outside of the building, you'll see that we have large overhangs. And when the sun is up high in the summertime, then that shade creates shade right at the window sill, so it protects. We don't get any sunlight, any solar penetration at all during the summertime in the high summer. So that's truly passive solar design, and it's intended to operate exactly that way. We did a little solar video in a three-dimensional CAD program to determine whether or not this was going to work for us in concept in the design phase. Hopefully next time we meet, I'll be able to show you some of the mechanical and electrical and plumbing that we've installed, and that will be starting to get ready for drywall and insulation.